Hello, welcome to this video for CS232, Intro to Mobile Platforms and Apps. Today we're going to be covering C# polymorphism, virtual methods, abstract base classes, and interfaces. So this is week 7, video number 1. With any luck, this will be the only video you need to watch for the first part of week 7, and I'll be back in class on the next class period on Wednesday. So the first thing we want to get started with is talking about polymorphism, and a good way to think about this is you always hear the phrase, we do things differently around here. You know, you might hear that at Google, for example, or a company that's hoping to hire new recruits. You know, everyone claims that they can do things better, you know, so if there's different bakeries around and they all do things differently, they all make their donuts a slightly different way, some taste better than others, but they're all essentially doing the same kind of thing. This is kind of what polymorphism is all about. It's implying that your methods that you're creating are doing the same kind of thing, but in a different way. So, for example, you'll be able to define classes that have similar functionality, but each actual implementation can differ depending on which exact version of the class that you're creating. Another good example in terms of software would be a web search engine. So as we know, the Yahoo search engine works quite differently from Google, and both of those work differently from Bing. They're all the same kind of idea, however. They all operate around this idea of you type something in and you get a search result back. They provide the same service, essentially, but in a different way. So this is sort of what R.B. Whitaker is talking about when he discusses inheritance. So you can say that there's a general thing to be done, and that is searching. And then the actual implementation can be done by a child of that thing, and that's what we call inheritance. So keep in mind that the child is the thing that is actually implementing, doing all the work behind the scenes, and the parent is the one that is essentially saying these are the variable things that can be done. In C#, that's how the inheritance idea works. So for example, let's say we were to make this hypothetical search engine class that we're talking about. We'd start with something that we call a base class. And that base class is, another word for that is the parent class. That's the class that all search engines are going to be made from. And for example, it would look like the following. You'd say class search engine, and then you'd have a method called something like search. So public virtual string search that returns an array of strings. In this case, it doesn't actually do anything. It just says return new string of 0. So it just says, you know, I've got nothing to give. And in fact, that's okay for the base class, because the base class is never going to actually return anything. It's the parent classes that are going to define how the search looks. Because what it's really doing is it's defining a single method called search. In reality, of course, we'd have lots of other methods for a search engine, but this is the important one in this case. So this would actually define us a method that is virtual, and that would allow the method to be overridden by anything with which derives from the search engine base class. And by derives from, I mean makes an instance of the search engine base class. So here's how you do that in code. You say class Google search engine, and then you say override string bracket bracket search, and then the actual parameter. Note that the parameter matches here. String find this matches with this one, string find this, and the rest of the signature matches as well. So here we say that we have no need to make assumptions about various searches that are going to be performed. All we need to do is define them in the derived child class. Okay, so here we see that the search method is overridden from the search method that was defined in the parent class. Here we've got public virtual search, which takes search string this, and here we have
Hello?
Here we have it returning new string, and here's some results that it's returning for the Google search. Notice that there's 3 different arrays. And so these three different possibilities are returned from the search method. So the override is needed to change the implementation for the derived class. Keep in mind, this is simply creating a new copy of that method. So if you look at this overall method here, public override string search, that is exactly the same as what is in the base class over here. And so here we say override string search. That's the keyword we're using instead of virtual. Anytime you use the public virtual string search, you can then use override in the derived class. So the base class needs to have that virtual keyword, and the derived class needs to have the override keyword. And what you're doing there is you're simply creating a new copy of the method, and then you put in your own custom-made implementation. And your custom-made implementation can be anything you want. In this case, we return an array of 3 members. Here are some great results, aren't they neat? And I found 1.2 billion things. But you will probably only search the first 10. Only look at the first 10. You don't have to override the methods. If you don't, the program will use just whatever was in the default base class. And for example, if we didn't override this, it would just return an empty string array in that first position. Now, what the beauty of this is, what we can do is we can add another search engine that is derived from the parent class search engine. And all we have to do is, again, our notation here is another search engine colon search engine, and then we have the new override search here, and this returns 2 separate arrays. It returns the I found something and I found this for you. So those are 2 separate arrays that it's returning instead of here are some great results and aren't they neat, which is what Google is returning. Another search engine is returning these 2 separate and different strings. Well, that's all fine and good, but you know, ultimately this is where it gets interesting. What you can actually do is any class derived from search engine and Google search inherit from the search engine class. That means we can use them anywhere a search engine object is required. For example, if we say search engine 1 equals new search engine, that's the plain old original one. But if we say search engine 2 equals new Google search, we can then say search engine 3 equals new RB search engine. But now we can use the search method anywhere, and depending on the actual type that you're using, you get the appropriate results. So if we say search engine 1.search, we get the results that are provided by the default. If we get search engine 2 search, we get the results provided by the Google search. If we say search engine 3.search, we get the results provided by RB's search engine. RB's search engine in this case is the same thing as another search engine. Actually, I'm going to change that so it makes it totally obvious what I'm trying to do here. This should have been called RB's because this was an example from his book. RB's search engine. So RB's search engine is the third one, the one that we called another search engine that we've defined from that. And if we call that, we get the results from RB's search engine. In other words, the I found something and I found this for you being the 2 members of the string array. So it's important to note that each of these calls a different and new method. Also, you can use the base keyword to access methods from the base class as follows. So if you want to access the methods from the base class, you just do base dot. So you do base period and then whatever the method name is that you're looking for. So in this case, base period search, find this, calls the version that's from the base class and sticks it into the original results. And in this case, it would write out that there's no results because, of course, we defined this to be an empty string. So this is the overridden string search, which would appear inside of the RB search engine or Google search engine in place of that. So our default search engine base class does nothing. It actually doesn't have to implement the search method. Other search engines do this for us, The other search engines are the ones that are doing the actual work. In this case, hold on a second here. So the other search engines are the ones that are actually doing the work in this case, and that therefore we don't actually have to define the search method in the abstract base class. So we might as well consider this an abstract base class. These classes allow us to have a parent class which itself contains no functionality. And in these abstract base classes, it's assumed that the children classes will fill this in. In other words, you're creating the idea of what a class is going to have, but you're never actually creating the thing itself. You could think of this in terms of the car analogy that I've used before, often in class, where you have a very abstract base class considered car. Well, no one's ever going to make something that's just a car. They're going to make a Toyota, or they're going to make a Saab, or they're going to make a Jeep, or whatever it is. They're never going to make an actual just car. Car is just this generic concept that all things share, which are derived from class car. This is the same idea with our search engine example. So for this, if you ultimately want to make something that's an abstract base class, you can use the keyword abstract. You say public abstract class search engine, and that way you don't have to provide a body for the search method. You just put the header, which is public abstract string search, and then you put a semicolon after it, and that now is your abstract method that has to be defined inside of any of the derived classes. Importantly, remember that if you do this, you cannot instantiate any abstract classes. So you can't, for example, do what we did back here where we created a new search engine. This would not be allowed because, or I'm sorry, this here would not be allowed because it's considered an abstract base class at that point. You would not be able to do that. However, you would be able to do both of these, the Google search engine and the RB search engine. Now, in some cases, that might be a good thing. You might not want to let users of your API create abstract base classes for things that don't really exist. That might be flagged as an error, for example, when you're using it. In a lot of cases, that's how you're going to want to treat these types of things. It's assumed essentially that whoever is implementing that class is going to define whatever it is that it does, and therefore you're going to choose a specific one for that fits that case. There's also a new keyword that you can use in a method. This designates that the method is not related to any of the other methods by the same name, and that will be only applied to that particular class definition. Another topic in Whitaker that I asked you to cover and read for this week is the topic of interfaces. These are a way of defining the things available to the outside world. So this is essentially the same kind of thing as an abstract base class, except they aren't ever really implemented. They can't be instantiated. The entire class is abstract, essentially, not just one method of it. This is the same idea of pure virtual base classes, where you sort of set the method to equal 0, if you remember that from C++ class. The whole idea here is that these are classes that give you the methods list of the things that possibly will be instantiated, or not instantiated, but possibly will be used inside of instantiated members of that class. So to make an actual instance of this class, you have to derive from the interface. So one example would be a file writer. For example, here's an interface for iFileWriter. So file writers in general have to be, they have to have specific files they can write, like XML files or HTML files or something like that. They can't be just generic. So this is typically how an interface is done for a file writer. You create an interface iFileWriter. You have extensions on it, sort of like get and set, and then you might have set. This one only has get. That just gets the extension. The get essentially just returns the extension, the extension variable that's a string, and then you have a write, and so this entire class cannot be instantiated. However, then you can create a text writer, file writer, that writes out the .txt file. So public string extension now, inside of its get function, it returns .txt instead of just returning nothing, like it does in this case. So it returns txt. So get is the thing that's being returned there, And then in the right, we actually do our actual file writing inside of this class. That's where the actual file writing for the text file would occur. For example, this is where it would actually open up the file with that file name and would write out the string to that file. So all the actual work would go on inside of here. This is here just to provide the names of the methods that the iFileWriter is going to carry over into the text file writer. So for example, if you had a XML file writer, it would look quite similar to this. It would just say XML file writer. So for example, let me just do that quick so you can see that this is exactly the same thing. If we said XML file writer, now you can see that now we have an XML file writer. So you can define a whole bunch of these, and you can have one that's a text file writer, one that's an XML file writer, one that's a HTML file writer, etc. And they all do their own thing. However, you know, they share this common interface, and for that reason you can expect that they have the right function on it, and then any generic can call the right function. For example, this is how you use it. Once you've used the colon notation and defined all your things, then you can create a new file writer. This is creating a new file writer array, and it's basically saying that file writers of 0 is our text file writer, here's our RTF file writer, and here's now our docx file writer. So of course we need to define each one of these, and then we could do a for each loop on all these file writers and just do file writer.write. So this is better than doing file writer.write, RTF file writer.write, docx file writer.write. Instead, it's just doing file writer.write, and the path and the file writer extension. It's doing essentially this job for each one of these types of files to write out using an interface class. One other note to mention is that C# doesn't allow for multiple inheritances. It does allow you to implement more than one interface. For example, what you can do is you can say public any old class inherits from iInterface1, iInterface2, and random base class. And in this case, if it does that, all the methods that are in each one of these are combined into any old class, and those are the ones that it has to define. We do sometimes see this in various Xamarin projects, so keep your eye open for that. Now, before we leave, I just wanted to show you quickly Xamarin project. This is the maps demo, and this is just what I've been working on here. Got the base code from the Xamarin site and then just started messing with it. You can see this inheritance here. Main activity inherits from list activity. That type of thing is done quite often in Xamarin projects. And then onCreate, of course, is an overridden function that overrides whatever is defined in list activity. So some of this terminology should start to look familiar now that you've seen this video. Here we've also got an onActivity result, which is an event-based thing where it returns the result of the map search. Here we've got an onList item click. This is what happens when a list item in the map demo is clicked. And here we've got a internal class being defined that derives from base class adapter. We've got another override. Internal classes, by the way, aren't very hard to understand. All they are is it's a class that can only be used inside of another class, so it's like boxed inside of that class, and you use the internal keyword to define those. So as you can see, the concepts we're using are very useful in real-life examples, such as this map demo.